Hello everyone, this is Mr. Underkoffler, and today we're going to be looking at the guided notes called Solving Equations with the Variable on Both Sides. Our key to success is to get the variable on one side first. That is your first goal. Now, how do we get the variable to be on just one side when it initially is on both sides? As I've taught you before, we're going to do that by adding the opposite of one of the variable terms, and we're going to do it to both sides. And so problem number one, this is already typed up for you, but follow along with me here on my screen. We have negative 15y minus 25 equals negative 22y plus 3. And so to get the variable to go to one side, we're going to add the opposite of one of the variable terms. And we're going to do that to both sides. When I say variable terms, I mean the terms that have the variable. So that would be negative 15y or negative 22y. And so to get the variable to go to just one side, we will add the opposite of one of those variable terms. So we could add the opposite of negative 15y, or we could add the opposite of negative 22y. It's honestly your choice. If you add the opposite of negative 15y, the opposite of a negative would be a positive, so you would add by positive 15y on both sides. And like I taught you the other day, you need to line up the like terms properly. So notice I did not put the plus 15y's underneath the minus 25 or underneath the 3. I did not, because they would not be like terms. You have to line them up properly. Another mistake that I've seen a lot of kids make is that they would accidentally say that they're just going to add by 15 and they lose the y. And then again, that would create an issue because then you wouldn't have like terms. And therefore, that would be mathematically wrong. So please, 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 please today, when you do this first step, where the goal is to get the variable from both sides to just one side, make sure when you add the opposite of the variable term that you have the variable with it. Otherwise, they're not going to be like terms, and it's going to be mathematically wrong. So, the debatable thing today is when do you need to make subtraction out of the opposite, when do you not? If you add by 15y on both sides, are you going to realize that that minus to the left of the 25 is why it becomes negative 25? I don't know. Maybe some of you would, maybe others of you wouldn't. If you think you wouldn't, then maybe you should make the subtraction out of the opposite. If you think you would, then maybe you don't need to make subtraction out of the opposite. So this is where I'm going to kind of start giving you some freedom here. You decide. All right, so anyway, that would give you the variable on just the right side. You would get negative 7y plus 3 on the right, and the variable is now gone on the left because negative 15y plus 15y gives you 0. It actually gives you 0y. We talked about this the other day. 0y means 0 times y, which is just 0, and 0 plus negative 25 is negative 25. So that's how that works. The other option would be to add the opposite of the negative 22y, which would be the opposite of a negative is a positive. So if you add by positive 22y, then you'll get 0y on the right, which is just 0. 0 plus 3 is just 3. Now on this problem, if you do it this way, making the subtraction out of the opposite, not really helpful, not really needed. I mean, you can handle having 7y minus 25, right? So again, I'm going to kind of start giving you the freedom here as to when you think it's going to make it helpful for you to make subtraction out of the opposite when it's not. Bottom line, when you have a minus to the left of a number, if that is the only thing that is remaining after you do something to both sides, then it's gonna pretty much make it a negative because the subtraction is the same as that in the opposite. So this is why some kids in algebra don't have to make it out in the opposite, because they already know from experience that the minus to the left of the number, if that ends up being the only thing that remains later on, then that's going to be a negative number. So the choice is yours. Now, from here, you would do inverse operations. You would ask yourself in your head what's happening to the variable, do the inverse operations in the order of SAD/MEP, which is the opposite of PEMDAS. We've talked about this so many times before. So, subtract by 3 or add by 25, depending which version of the equation you have. Then later you would divide by whatever number was multiplied to your variable. Now, for those of you who do not like negative numbers, maybe you would want to choose the choice where you would add by 22y on both sides, so that way you get a positive 7y. So maybe you want to think a little bit ahead to working smarter, not harder. If you don't like negatives, then make sure your first step would give you a result where you would get a positive. Now, sometimes you're never going to get a positive coefficient of your variable, but other times you could. So if you can think ahead and work smarter, not harder, then maybe that would be helpful on some of these problems. But there is the type of equation like number 2 that I want to talk about. Number 2, notice the right side is not a variable term plus a constant. It's just a variable term. Whenever you have an equation like that, then don't bother trying to keep positive numbers. Instead, get the variable on the side that only had the variable term, which in this case is on the right side. So, therefore, I would add by negative 6x, because that would give me negative 4x on the right, and look what I end up having. A super short equation with only one thing happening to the variable. Multiply by negative 4, so we divide by negative 4. And look how quick that was to solve. So, if you ever get a problem like number 2, where one of the sides of the equation only has a variable term, then I highly recommend that you get the variable on that side. That would be the quickest way of doing that problem. Speaking of which, take a look at number 3. It's those type of problems, just like number 2. Let's see if you can do it in the quick way like I was showing on number 2. So hit pause in the video, try number 3 on your own, then hit play when you're ready to see how you did. Okay, I hope you already did number 3. Let's see how you did. Now, did you add by positive 8w? If you're like, whoa, I thought I should add by negative 8w. You see how there's subtraction to the left of that 8w? Since subtraction is the same as adding the opposite, then that already was negative 8w, and therefore to get the 0 that you need to make the variable disappear from that side, you have to add by positive 8w underneath on both sides. So if you messed up, hit pause, fix your mistakes, then hit play when you're ready to see how you did. Okay, so if you add by 8w, you will get 0 on the right plus 46, which is just 46. Left-hand side gives you 18w. And now you have a nice, short, and sweet equation that you can solve very quickly by asking yourself what's happening to your variable. You can see your variable is being multiplied by 18, and the inverse of multiplication is division. Please do not think that you're going to add by negative 18w on both sides. No. That's the kind of thing you do when you have a variable on both sides and you're trying to get it on one side. Once you get the variable on one side, then you ask what's happening to the variable and you do the inverse of what's happening to both sides. And so the variable was multiplied by 18. That's why you now divide by 18. That will give you W equals 2.5 repeating, or 2 5/9. I know some Casio calculators will give you the answer as an improper fraction, which I believe would be 23/9. I would accept the answer any of those 3 ways, but usually we'd rather have it as a mixed number or as a decimal, repeating decimal in this case. So there you go. That's how number 3 works. Okay, problem number 4. Now this one's already typed up for you. Follow along with me. We want to get the variable from both sides to one side. There's two ways to do it. First of all, you need to realize subtraction is the same as adding the opposite. So we could add by positive 4c to both sides, or we could add by negative 2c to both sides. But if you do not like negatives, and you don't want to have to deal with negative signs, then think which way would give you positive results. If you add the opposite of negative 4c, which would be positive 4c, then you will get positive 6c plus 35, and then on the left side, just the 7. Hey, there's not any negative then for the coefficient of the variable. Maybe you like that. Maybe you do. I don't know. Then from here, you would ask yourself what's happening to your variable. It's being multiplied by 6, then added by 35. So the inverse would be to subtract by 35. Do you need to make it out in the opposite or not? Maybe, maybe not. It's going to give you negative 28 equals 6c. You would divide by 6 because that's the inverse of multiplying by 6. And that gives you negative 4.6 repeating, or negative 4 2/3, or an improper fraction. It's your choice which way you want to give it. And that's how that problem works. All right, so now we have number 5 and number 6. Now, of course, there's two ways of doing this. I'm going to pick the way that gives me a positive coefficient for the variable. If you want to be able to check your own work, then I suggest that you figure out the way to get the positive coefficient on the variable. And that will determine what you do to get the variable on one side. So keep that in mind as you try these two problems on your own. Let's maybe just start by having you get the variable on one side. So get the variable on one side of number 5, and then get the variable on one side of number 6. Then hit play when you're ready to see if you did that part correctly. Okay, did you get the variable on one side of number 5? Did you get the variable on one side of number 6? Let's find out. Problem number 5. To get the variable to go to one side and to keep it as a positive coefficient, since that minus 8u is the same as plus negative 8u, you would add by its opposite of the variable term. You'd add by positive 8u to both sides to get your 0 on the right, and then you're left with positive 17u on the left side. That's how you can get a positive coefficient on the variable and to get the variable on one side. Now, full disclosure, the other option for number 5 would have been to add by negative 9u. If you did that, then you would have got 106 equals, and then instead of having a 17u on the left, if you add by negative 9u, then you would have a plus negative 17u on the right. Now, I'm not going to show it that way on my screen, but if you did it that way, it is technically correct, but then you're going to have quite a few more negatives than what maybe I will. So maybe, maybe that's helpful, maybe it's not. Problem number 6. To get the variable on one side, you could add by negative 25y on both sides, or you could add by negative 24.5y on both sides. I chose to add by negative 24.5y because then I get a positive 0.5y on the left. Then minus 18 or plus negative 18. Maybe you make it out in the opposite, maybe you don't. And then equals 14 on the right. If you did it the other way, if you added by negative 25y on both sides, then you would get negative 18 on the left, and instead of having 0.5y on the left, you would have plus negative 0.5y on the right. Now, I don't prefer having it that way. I'd rather have a positive coefficient of my variable, so I'm not going to keep it that way. I'm going to keep it my way. All right, now that we have the variable on one side, hit pause on the video again and finish solving both number 5 and then number 6. Then hit play when you're ready to see how you did. Okay, I hope you finished solving number 5 and finished solving number 6. Let's see how you did. Number 5, since the variable is being multiplied by 17, but then added by 106, you would do the inverse of adding by 106, which is subtracting by 106. That would give you negative 85 and 17u on the left. Divide by 17 because that's the inverse of multiplying by 17, and you'll get u equals negative 5. Number 6, since the variable is being multiplied by 0.5 and subtracted by 18, do the inverse of the subtraction piece first. That would be adding by 18. That's going to give you 32 on the right. You'll get 0.5y on the left. Then you do the inverse of multiplying by 0.5, which is dividing by 0.5. Now, that does not give you 16. Dividing by a half is not the same as dividing by 2. You're going to get 64. Now, why does that make sense? Because dividing by 0.5 is the same as dividing by 1/2. And dividing by 1/2 is the same as multiplying by its reciprocal, which would be 2. And 32 times 2 gives you 64. That's why 32 divided by 0.5 gives you 64. Do not forget that dividing by a fraction is the same as multiplying by the reciprocal. That type of number sense is very helpful to know. Okay, 2 more examples for you at the top of the second page. Again, we are going to get the variable on one side first, and the way that we do that is by adding the opposite of one of the variable terms. Here I added the opposite of 1x, which is negative 1x, because 1x plus negative 1x is 0x, which makes the variable disappear from that side. Don't forget, x is the same as 1x. We had some problems like that the other day, so that's why I wanted to show you number 7. Once you get the variable on one side, I think you guys should know what to do to finish solving your problem. Now, you might get some fraction coefficients like we have on number 8. Don't be intimidated by them. You do have a scientific calculator. But reminder, number 8 had only a variable term on the right side, and so I chose to get the variable on that side because then, after I get the variable on one side, since I got it on that right side, then I only have one thing happening to the variable that I have to do the inverse of, which of course would be dividing them by negative 1/3. And so that makes number 8 quicker to finish because I chose to get the variable to go to the side that was shorter, and that made it quicker to end up finishing to solve. So again, that was just a quick reminder of equations where one of the sides only has a variable term. All right, so now that I've talked about 7 and 8, there are many problems remaining. Number 9, number 10, 11, 12, 13, and obviously also 14. I want you to do each of those problems. So hit pause on the video, finish the problems on this page, then hit play when you're ready to see how you did. Okay, I hope you have already done numbers 9, 10, 11, 12, 13, and 14, because I am now going to go over them. Here we go. Problem number 9. You could add by negative 1w to both sides, or you could add by negative 9w to both sides. The choice is yours. For those of you who added by negative 1w, you're going to get 55 equals 8w minus 41. Then you'll do inverse operations. You'll add by 41. You will later divide by 8. That will give you 12. For those of you who added by negative 9w to both sides, please remember that the w up here is the same as 1w. And then you will get negative 8w on the left plus 55 equals negative 41. Now, why was it negative 41? Because minus 41 is the same as plus negative 41. That's how you end up with negative 41. If you can do that without making subtraction out in the opposite, then all the power to you. But those of you who are like, oh, nope, I would have thought it was positive 41, then maybe you should make the subtraction out in the opposite in that situation. From here, we're going to do the inverse of adding by 45, which is subtracting by 45. If you want to do this without a calculator, maybe you make this piece over here out in the opposite. Maybe you don't. Choice is yours. That's going to give you negative 96. You'll have to divide by negative 8 on both sides. So this version had a lot more negatives. Maybe this is not the version that most of you then wanted to choose. Choice is yours. Hit pause if you get to check your work a little bit longer. Moving on, number 10. Again, two ways of doing this. You could add by negative 0.4m. You could add by positive 6m. If you add by negative 0.4m, you will get negative 6.4m on the left. If you add by positive 6m, then you will get 6.4m on the right. If you got negative 6.4m on the left, then you're going to add by 414 on both sides. You will later divide by negative 6.4 on both sides, and you'll get negative 65 as your answer. If you did it the other way, you will add by negative 2 or subtract by 2. Same thing. Subtract by 2, add by negative 2. They mean the same thing. That'll give you negative 416. You'll divide by 6.4, and you will get the exact same answer that you got the other way, which is negative 65 equals m. Problem 11. You could add by 2r on both sides, because that's the opposite of negative 2r. Or you could add by positive 8r on both sides, because that's the opposite of negative 8r. If you add by 2r, you're going to get a negative 6r on the left. Maybe you don't like negatives. Maybe that's not the best way. But if you did it that way, then you'll subtract by 22. That'll give you 54. Then you will divide by negative 6, which gives you the final answer of negative 9. Number 11, the other way of doing number 11, if you add it by 8r on both sides, you'll get positive 6r on the right. Maybe that's nicer. Then you'll subtract by 76. But then that will give you a negative 54. So you are going to get a negative number some way, either way you do this. Okay? Then you'll divide by 6 on both sides. That will give you negative 9. Number 12. Again, two ways of doing it. You could add by negative 1/2 h on both sides, or you could add by negative 1/4 h on both sides to get the variable to go from both sides to one side. You can see here what the results would be. If you added by negative 1/2 h, then you're going to get negative 1/4 h plus 7 equals negative 6. If you added by negative 1/4 h on both sides, then you don't have as many negatives to deal with, so maybe that's the nicer way. I don't know. Please realize, since subtraction is the same as adding the opposite, that is how you get a negative 6 over here if you did it this version. Otherwise, you could have kept it minus 6 over here on this side. Plus negative 6 is the same as minus 6. I honestly don't care which way you do it. So you're going to add by 6 on both sides if you did it that way, or add by negative 7 on both sides if you did it that way. You'll get negative 13 equals negative 1/4 h over here on the left, or 13 equals 1/4 h over on that side. Doing it that way, you'll divide by 1/4. I hope you know that dividing by 1/4 is the same as multiplying by the reciprocal, which is multiplying by 4. And that's why 13 divided by 1/4 is the same as 13 times 4, which gives you 52. Doing it the other way, you're going to have to divide by a negative. You have lots of negatives here, but a negative divided by a negative gives you a positive. Okay, number 13. You could add by positive 5d on both sides. I hope you see why. Negative 5d plus 5d gives you 0. That's going to give you negative 9d. And then you'll divide by negative 9, and you'll be done. So, really, that's the best way. By far, that's the best way. If you did it the other way, adding by 14d on both sides, you would get 36 plus 9d equals 0. You may not make that 0 disappear. You're going to have to subtract by 36 on both sides, which will give you negative 36. Now, why does that give you negative 36? Because subtracting by 36 is the same as adding by negative 36, and 0 plus negative 36 is negative 36. Divide by 9 on both sides. Now, notice, it's the same answer as the other way that I did it. But the other way I did it, where I got the variable on the side that began with only a variable term, that's the quicker way to do it. Finally, number 14. I want to get the variable on the side that will make this the quickest. So I would add by negative 7/8 x, which gives me negative 1/8 x, divide by negative 1/8, which is the same as multiplying by the reciprocal, which is multiplying by negative 8. And that will give you the answer of negative 232. Yes, you could have added by negative 3/4 x to both sides, but that would have been longer, and I don't want to do the long way. I know I showed it to you both ways on, what was it, number 13? But ladies and gentlemen, do it the quickest way, because hey, doing things quicker is nicer whenever possible. All right, so that concludes the guided notes here on solving equations with variables on both sides. Thanks for watching the video. We'll see you next time.